Hi. Thank you, Kelsey. That was amazing. Almost made me cry. That is not cool. Anyway, today I'm here to tell you a story. I'm here to tell you a story about my relationship with Neil, how I discovered it, and I went through this weird relationship where at the beginning I kind of ignored it. Then I kind of hated it a little bit. Neil is annoying, right? And then I started understanding a little bit more. And now I could say that it's kind of almost love. I'm not going to use love. It's a hard word for Neil, really. But, I appreciate it. So I'm going to tell you why I think Neil something actually pretty cool. Before that, I wanted to thank a couple of people. Actually, first of all, I want to thank the GopherCon team for making such an amazing conference. This is amazing. So a round of applause for Eric and Brian and the rest of the team. They're amazing. And I also wanted to thank the Go team, because without them, I could not be here today. I wanted to thank Rob Pike for saying yes when I interviewed with him 4 years ago. And also to Andrew Duran for being such a good mentor. He's awesome. Anyway, also I wanted to welcome you to GopherCon. And I wanted to welcome every single one of you, regardless of your gender identity, your sexual orientation, your race, your religion, and even if you prefer spaces over tabs, you are part of this community. And the community is better because of you. So welcome to GopherCon. Okay, so I'm going to be talking about nothing all the time. So I'm going to first explain what is nil, what does it mean nil, what does it mean in the Go context, and is it actually useful? Spoiler alert, it is. Otherwise, this could be a really bad talk. So, first time I saw nil, I was like, no, you misspelled no. Like, that is not how you write it. I did not know this word. You might be surprised I'm not from here, so English is not my mother tongue. And what do I do when I discover a new word? Google Translate. And I knew that no was nul in Catalan, my mother tongue. So it was like, easy. Then I looked for nil, and it is nul. I was like, oh, okay. So it might be the same word, but I'm not really sure, so I go to the dictionary, and I find definitions that don't really help, like a little bit too philosophical. And I love languages. I love etymology. So I said, let's see the etymology. And I saw that nil came from nihil, and from Latin, and it means the nothing, the concept of nothing. While null and none, which are other words that are pretty similar and we use in other languages, mean the lack of things. And I thought, that is cool, but I still don't get it. So I went to the source of all truth, Wikipedia. And I found the list of words that mean zero in English, and nil and null were there. I was like, oh, that's cool. Duck also is there, so you can technically say zero typing, and it is fine. So anyway, nil is a kind of zero. That's what nil is, after all. And when you think about zero, before we start talking about what is zero in Go, I wanted to talk a little bit about the history of nil. So the history of nil is quite interesting because it starts with someone that we all know and appreciate, Tony Hoare. He wrote Communicating Sequential Processes, which we all have read, right? Anyway, it is basically the book that set the basis for what it could become later on, the concurrency features that we have in Go, both Go routines and channels. The bases are from here. So, Tony Hoare, kind of an important person for the Go community. And then he also created nil. He created nil in Algol W in 1965. Basically added two different things to the language, to Algol. They added both records, which we call structs, and references, which we call pointers. And as soon as he was done, he decided, oh, let's add nil. Why not? It is easy to implement. And during one of his talks that I recommend you watching, it's called No Reference, The $1 billion Mistake, says that it was actually not such a good idea. And I mean, he created it, right? And he says it is a huge mistake, $1 billion mistake. That's a lot of money. And still, I kind of disagree with him, at least in the context of Go. But I understand that if the first time you see nil, it is because you get a panic, or the first time you see undefined is because it's not a function, Or the first time you see a pointer in Java is because there's a null pointer exception, you are not happy, and that you associate nil to panic, and we all know panic leads to fear. And fear leads to functional programming. And this is a joke. This is a joke, but there's actually a little bit of truth in this statement. Because if you think about functional programming, they actually avoid having nil pointers by using other things, like monads, option types, or other kind of different constructs that allow you to not have nil. And they're really good. I actually love functional programming. I gave a talk, .go in Paris last year, which is functional Go. It is not functional Go, it's functional Go with a question mark, and the answer is thanks, but no thanks. You should not do this. This is definitely a bad idea. But I actually learned enough to basically implement monad in Go, the maybe monad. And it did not make it so much better. And I thought it was because maybe monads were not as good as I thought they were. But now I understand that it is because nil is powerful enough in Go as it is. So yeah, there's many ways of dealing with this kind of problems. But Go has nil, and nil is the way to deal with things in Go. So let's see how it actually works. OK, so we said nil is 0. What are 0 values? We talked about them all the time in Go, right? Like, if you declare a variable, and you give it a value, it will have a value. It will never be undefined. It will have the value, which is the 0 value of the type. So if you have a Boolean or a number or a string, it is pretty obvious. False, 0, empty string. But if you have a pointer, you get nil. You have slices, you get nil. You get maps, you get nil. Channels, functions, and interfaces, you get nil. So nil is kind of important. It is the 0 value of most of the types in Go, after all. So let's try to understand a little bit better what it is. Oh, and by the way, for a struct, the 0 value of a struct is simply a struct that has every single field, it's 0 value. So if we have int string and slice, you will get 0, empty string, and nil. So we see that the value of nil is 0, kind of, but what is its type? It is a pointer, it is a slice, it is a map. So I went to read the Go specification, which is a great document, and you should all read. I think that it is surprisingly easy to read, and every single time you read it, you will learn probably something. And it says at some point, unless the value is the predeclared identifier nil, which has no type. What? Nil has no type. OK. So it is not like other 0 values. We have false has a type. It is Boolean. Empty string and has also a type. Even 0, that does not really have a type, it will actually have a type. We'll say it's int. The compiler will change that. 0.0 will be float64. But nil will just not compile. There's really no type. So that is surprising. OK, so we don't have a type. We keep on reading about it. And I kept on reading on the documentation of the built-in package, where all the predefined things are, like int and bool and nil. And it says the nil is a predeclared identifier that represents the 0 value for pointers, channels, funcs, interface, maps, and slices. Cool, we know that. But predeclared identifier. I thought nil was a keyword. It is not a keyword. Interesting. These are the keywords in Go. There's 25 of them, unless you count the ones that are secret. So what is going on? If nil is not a keyword, what is it? Well, it is something that you can redefine. And you should never do this. This is a really bad idea, but the code will compile. If you want to make it as a joke, I recommend putting it inside of doc.go at the end, right after package. It is the perfect place to hide it. Anyway, you should never do this. But it is doable. It is a predeclared identifier, not a keyword. Great. So what are 0 values, after all? We have all of these types, all of these kinds of types. Let's see, for every single one, what does it mean to be 0? For pointers, we need to understand first what a pointer is. And a pointer is simply something that points to an address in memory. That's it. And it is like C or C++ if you've done any of those languages, with a couple differences. One of them is the fact that we don't have pointer arithmetic, which means that you cannot get an address of a variable at 4 and see what happens. You can actually do it with a package named unsafe for a very good reason, and you should not use it unless you really need to. And then also the other difference is we have garbage collection. So what is a nil pointer? Something that doesn't point to anything. That's it. Cool. And is the zero value? Easy, pretty simple. What about slices? This is a little bit more interesting. Because slices, when they're nil, so a slice has actually 3 values. It has a pointer to a backing array, and then a length and a capacity. So if you imagine that we're creating a slice of 5 bytes, we're actually pointing to a backing array that has 5 bytes in it. And then we know that the capacity and the length are both 5. If you I removed that slide today. If you subslice it, you could get something different. But the nil slice, it is simply a slice that doesn't have a backing array. That's it. Length and capacity are still there, and they're 0, but there's just no backing array. Cool. Maps, channels, and functions are pretty much all the same style. And the interesting thing is that maps and channels, they actually used to be pointers. If you see on GitHub, you go back to 2008, you will see that maps have star map, and channels have star chan. But we changed that. The implementation is still the same behind the hood. So it's still a pointer. And same for functions. So they're just simply something that points to something. What is that something? This talk is not long enough to get in detail, so it points to a cloud, the implementation. And what is a nil channel, a nil map, or a nil function? It is a pointer without the cloud. That's it. It's not initialized. And now we're going to talk about interfaces. And this is where it starts getting interesting. Because there is something that can shock some people at the beginning when they discover nil interfaces. An interface is not a pointer. An interface has 2 components. An interface has a type, the concrete type of the value that is inside, and also the value. So if we declare a variable of type stringer, which is an interface from the func package, we'll have the concrete type. We have not given any, so it will be nil, and the value will be nil. So we compare that to nil, everything works, everyone's happy. Nil, nil equals nil. Good. Now, we have a pointer to person, and that pointer to person is nil. Person satisfies the stringer interface, obviously. And we put that nil pointer inside of a stringer interface. So now, the concrete type is pointer to person, but the value is nil. And that is not nil. Pointer to person nil is not nil. And this is something that seems confusing, and it might seem like it is something we don't really need. But still, we do. So when is nil not nil? Is that a thing? And it is. Let's see this code that I totally wrote just for this, and I don't think that anyone could write this. And if you write it, don't do that anymore. Where I'm predeclaring an error, and that error will be a pointer that happens to be nil, and I'm returning that error. What happens here? Well, error at that point is a nil pointer of type pointer to error, pointer to do error. But when we return it, we're wrapping it in an interface, and that nil pointer becomes an interface that has a nil pointer inside, and that is not a nil interface anymore. So when we compare it to nil, it will say, nope, this is not nil. And if you print it, you will get nil. So do not declare concrete error variables. It is a bad idea. In general, you should try to avoid it. Another case that happens, and I've seen this for real on GitHub, it is you return a concrete pointer to error rather than the error interface. And this code totally works. You're returning a pointer. You compare that pointer to nil. So you're comparing a nil pointer to the nil value for pointer, and they're indeed equal. So everything works. Later on, maybe ages later, someone adds that wrap do. Everything is doing just calling that function. What's happening now? Well, do still returns that pointer to the error. But now wrap do wraps it inside of an interface, so your code is broken. So do not return concrete error types. It is a bad idea. So keep in mind that nil is not nil for some kinds of nil. And the important thing here is to think about the fact that nil is not just nil. A nil slice is a nil slice, which is different to a nil pointer, which is different to a nil interface. So if you want, you could totally call them something different. And you could call a nil interface none. And I wonder what Go could look like if we had that. It could be maybe a little bit less confusing, or maybe a little bit more confusing. I'm actually not sure. She disagrees. So yeah, we should keep it as it is. Great, so we've seen the kinds of nil, and what do they mean? We've seen that pointers just don't point to not anything. Slices don't have backing array. Maps, channels, and functions are not initialized. And finally, interfaces don't have any value at all, even nil pointers. So, Ropak says, make the zero value useful. And he is also one of the designers of Go. So one could hope that the zero values of Go are useful. So let's see how that is true. So how are these useful? Let's start with pointers. A pointer is completely useless, right? You cannot do anything with it. Everything you can do is compare it to nil, and it will say true. If you try to dereference it, which is the only thing you can do with a pointer, it will panic. OK, let's write some code. This is not an interview, so don't panic. We have a tree, a binary tree, and we want to implement sum. Okay? And I'm pretty sure that you've all seen some of this code. Basically, what you want to do is just go through the root and go through the trees and all that stuff. So if you asked me to write this, I could probably write some code like this. I start with the root, and then I see if there's something on the left, I go through the left, something on the right, I go to the right. And this totally works. But there's a couple things that I don't like. One of them is the repetition of code. If there's something here, do something here. And the other one, which is a little more serious, is that the nil pointer to tree, sum will fail. You will get a panic. So let's see, why is this, and can we fix it? Let's imagine that we have a person, which is a struct, and we define a function that receives a pointer to a person, but it doesn't use it at all. Why could that panic? Same thing for methods. Why could that panic? You're not using the pointer. You're not dereferencing it. It will just work. And this is different to many languages. This is different to Java. This is different to C++. So it is something that we might not think about. But this totally works. So using that, let's see how we can improve our code. Keeping in mind, nil receivers are useful. We can write this code. In this code, everything we're saying is, well, if we get the nil tree, which happens to be the default value of pointer to tree, we return the 0 value for the int, which is 0. Great. This looks much better. What if you wanted to do string? Well, the 0 value for string is empty string. Otherwise, you just put the rest together. What if you wanted to do find a value in that tree? Well, same thing. You just return false, which is the 0 value for Boolean. So you can imagine how all of a sudden you can make your types useful. So nil is useful, and whenever it is possible, you should try to make your default values, which might be nil, useful. And if not, you should define a new function that will return something that is actually useful. Great, let's talk about slices. Are slices useful? Yeah, they're awesome, actually. You can do everything with them, absolutely anything. The only thing you can do is get an element from a slice, from a nil slice. Why? Because it's nil? No, because it's empty. There's nothing inside, so obviously you cannot get anything from it. But you can append into it. And this is actually a very normal idiom in Go. Well, you're going to be writing code. You're going to be appending stuff to a slice. You don't need to pre-declare how long it's going to be. You start with nil, and that's it. And some people might be, oh, no, but this is not performant enough. And it turns out that I disagree completely with that. Because, yeah, when you start doing this code, where you're appending and printing, the important thing is the capacity. At the beginning, it's 0, because the slice is nil. And then we need to allocate something, size 1. Then we add 1. Actually, we double it. Then we double it again. Then we double it again, and so on. Which means that the cost of adding elements is actually not that bad. If you're adding 1,000 elements, you're going to have 10 reallocations. If you prove with pprof that those 10 allocations are slowing down your program, then I'll be happy at the make. Before that, you'll need slices. They're, in general, fast enough. Let's talk about maps. Maps are kind of like slices. You can do most of the things with them. You can actually check if something is in a map. But you cannot add elements to the map because it is not initialized. Sorry. So are they useful? Well, let's imagine that we had a function like this, new get. You don't need to understand the whole code. Everything this is doing is you give it a URL, you give it a bunch of headers inside of a map, and it will return a HTTP request, sending that request to the URL with all the headers that you gave. And I'm going to send a request to google.com with Golang Gopher as user agent, because why not? And that works. What if you wanted to send it with no headers? You could send this, and this could work. But better than this, you can send this, because nil is a completely valid value if everything you're doing is reading from it. Iterating works, getting keys work. And it still works. So in general, if what you're using is a read-only empty map, nil is completely useful. And it's shorter, and in Go, we like short things. Let's talk about channels. And this one is my favorite, probably. And I totally copied from Dave Cheney. But I kind of modified it without your permission. I hope you don't mind. Anyway, nil channels, you cannot do anything with them, right? If you try to send something, it blocks forever. If you try to receive something, it blocks forever. If you try to close it, it panics. So nothing works. Coding time. Imagine that I ask you to write this function, merge, that given two channels, it's going to be reading from those two channels and sending the result into an out channel. From A, I'm going to be receiving ones, and from B, I'm going to be receiving twos. So in out, you should be seeing ones and twos. Cool. I write this code. Select statement for the win. Easy. Cool. So everything I'm doing is if I receive something from A, send it to out. If I receive something from B, send it to out. And I run this code. And I get twos and ones, but I get mainly zeros. And why is this? Oh, because it turns out that on a closed channel, if you receive from it, it will not block. It will just give you a 0 forever. So all of a sudden, what we're doing is we're just getting twos and ones, then both channels close, and now we're just receiving zeros all the time and sending them down to out. So let's fix that. Instead of having this code, we're going to check if the channel is closed or not. And we can do that with the v, OK syntax. So we're going to say, we're going to have this Boolean that says, is A closed, is B closed? And we're going to update it whenever the channel closes. And then on top, and I'm sorry if you cannot read it on the back. I did it as big as possible, but this is a very long room. We have those Booleans, and we iterate for as long one of those channels is open. We run it. It works. And then it panics. So close. What's going on? Deadlock. Because our receiver, once we close both channels, is still waiting for something to happen. We need to close out. Once we're done, we need to close that channel. Cool. We add that. We run it. It works. Woo! Party time. We ship it. Obviously, who tests? So we ship it. And it's in production. And someone calls us like, hey, so that code, yeah, the data center is on fire. Oops. So how do you test things? Obviously, you add logging. So what I'm going to do is I'm going to add a log line every single time we see the channel is closed. I run this again, and I see B is closed, B is closed, B is closed, 1,000 times B is closed, and finally, A is closed. So what is happening is that we're reading from that closed channel continuously. That orange case where we're reading from B, as soon as B is closed, that case will never be blocking, which means that we're actually in a busy loop going around like crazy and heating up our CPUs until our data center gets on fire. Bad thing. So can we switch off a channel? That is what I want to do. I don't want to close it. I want to be like, you're done. Stop it. Well, we have nil channels. And nil channels, when you try to receive from them, it blocks forever, which is exactly the opposite as closed channels. So what if instead of saying, oh, the channel is closed, we set the channel to nil? Now what we're doing is we are deactivating that channel. And that case statement will never, ever be active again. So now, with this code, if we run it, it works. Party time. This is my favorite Gopher, by the way. I'm very, very excited about René's French talk tomorrow. I want to see if there's new Gophers. But so far, this is my favorite one. OK, so use nil channels to disable select cases. Functions, I'm going to go pretty fast on this, because they're here, in my opinion, for completeness. If you have a struct that has a field of type func, which is totally possible because functions are first-class objects in Go, then what is the zero value for it? Does it mean if we don't have a zero value for functions, does it mean that then we don't have zero values for structs with functions? That is not good. So, and obviously, the only good solution is having nil. But also, it can be used as an indication of the default value. So in this code, for instance, what I'm doing is I'm passing a function that I'm going to use to log stuff, logger. And if logger is nil, which can be nil, I will just say, I'll just print with log printf. And this is something that you can do, and I've seen many libraries doing that. So nil for funcs can be used to imply default values. And I want to finish with interfaces. And interfaces is interesting, because how many of you have written this line of code? Yeah, we all have written this line of code. And that is a nil interface. So nil interface is the most useful value ever. And it actually means everything went fine, which is the opposite of panic. So a nil interface is actually a great thing to see. But why is it that a nil pointer and a nil interface need to be different? Why don't we just unify it and a nil pointer is a nil interface and that's it, and we're done with it? Well, let's imagine that we have this interface, summer. It is very hot, too. We have summer, which is an interface with the sum method that returns an integer, kind of like the tree. So we can use a nil pointer to tree inside of a summer value, and that is totally valid. And it is valid even though t is nil, calling sum will return 0, which is exactly the value that we want. So a nil pointer can be a totally valid value for an interface. If we define something which is a slice that has the same method, and it just does the sum of the slice, using a nil slice, we can still satisfy the interface. So nil values can satisfy interfaces. In an interface, if we have a function that is receiving an interface, we should not care about whatever value is behind. We just care about the fact that those methods are there. So the fact that behind there's a nil pointer, a nil slice, or even a nil channel, we don't really care. We can also use it to have it as default values, kind of like functions. And you can imagine here, I have a func doSum that simply checks if the summer that I receive is nil or not. If it's nil, I will just say 0, because whatever it is 0, and I'm fine. Otherwise, I will actually call the function. And this is something that we actually do very often, where the nil interface implies just go with the default thing. We can do it. So we can call this function with any of those values. The last one is actually nil, and it will still work. But how many of you have seen this line? This line of code, the last nil, it actually means use the default behavior for HTTP package, which is to use the default mux. So you could send your own handler if you want to, but you don't need to. So you're saying, I'm saying nil, use the default value. So you can use nil interfaces to also signal default values, and also to signal that the error is nil, so we're happy. Great, so I hope you agree with me that nil is useful. And we've seen that nil pointers are very useful, and nil pointers, nil receivers are totally valid. And whenever it's possible, you should try to make your nil pointers useful. We've seen that slices are just perfectly valid empty slices. Maps are perfectly valid read-only maps. Channels are not useful, but essential to some of the things that we want to do with concurrency. Functions are there for completeness, and interfaces are a very good way to signal things in Go, like default things, and error is not nil. So I think that nil is a very important part of Go. As we've seen, it appears basically everywhere in the language. So stop thinking about nil as the error case, the thing that you should try to avoid, the billion-dollar mistake. And instead, let's think about the fact that if it's such an important part of the language, by understanding it and embracing it, we'll better understand and embrace Go. Thank you.